All right, thank you very much. This afternoon's presentation, I won't necessarily have a lot of time to go through a bunch of details and such, but I do want to make the case for upping our game on pedestrian facility design, sort of in general. All of us are pedestrians at some time or another. And a little quotation from a famous book all you engineers will be pretty familiar with. The interactions of pedestrians with traffic are a major consideration of highway planning and design. This is from the AASHTO policy on geometric design of highways and streets, the old green book. So what I want to do is talk about our pedestrian. We have a sort of a three-prong approach that we're trying to roll out, talking about pedestrian mobility, pedestrian accessibility, which we've been working on, and pedestrian safety. And that's what I want to talk about this afternoon, is pedestrian safety. What I've thrown up here is a graph of our pedestrian fatalities here in the state of Texas. Across the horizontal axis is the calendar years from 2006 through 2016 when we have our last data. And then up the vertical axis is just the fatality numbers. These are the pedestrian fatalities. So you can see from 2006, it's up, up, up. We had a bit of a lull in 09 and 010. This correlates almost exactly with the overall fatality rates that we experienced here in Texas. I'm not a safety expert, but some conjecture as to why that was. Those were the recession years, if you'll remember, and so the general VMTs and all that were down somewhat. But again, after that, up, up, up we go again. Another little plateau in 12, 13, and 14. But as you can see, after 14, we had a significant jump into 2015. We had a very significant jump into 2016. I checked the numbers over the weekend, and we're over 400 right now for 2017, so we're well on track to meet or exceed these rates for the current year. So I think it's something that we definitely need to pay attention to, and we need to seriously take a look at, what are we going to do? How are we going to bring these numbers down? One of the concepts that you'll learn about when you talk about hazardous materials is the risk being a function of your exposure and the toxicity, in this case, of a chemical, say. So something that's highly, highly toxic, you just barely need an exposure to bring your risk rate way up. Something that's less toxic, like aspirin or water, obviously, given enough exposure to it, can be fatal as well. So if we take that same sort of concept of risk being a function of exposure, and we won't necessarily toxicity of the environment, but maybe the morbidity or the fatality of a collision. So the next little graph I'm going to show you is a function of impact speed for pedestrians, and then the expected fatality rates going up the vertical axis. So if you look at these speed of impacts coming across the bottom axis, and then the percent fatalities that you might expect going up the curve, you can see it goes up pretty rapidly. Now there's an interesting thing about this particular graph. You'll notice at the lower speeds it's very, very flat curve. It doesn't go up much. Incidentally, or maybe not coincidentally, if you calculate the speed at which humans under our own power can travel, ran the calculation numbers for the current world record 100-meter dash, which I would argue is probably some of the fastest that humans can travel under their own power. You run those numbers, Usain Bolt's world record 100-meter dash, he's running about 23, 24 miles an hour. So you'll notice at about 22, 21, 22, that curve is pretty flat, but soon thereafter, it shoots up. It shoots up in a hurry. So I show you this to make the point that speed is absolutely critical in the pedestrian environment when we're talking about crashes, okay? Now, let's talk about the exposure piece of it. And this little graph is a two-part graph. It's basically the population of the state of Texas, okay? These are our customers. These are the people that we are working for. So the blue bar graph, again, this is the census years are across the horizontal line of this graph, and going up the left-hand side, which is the blue bars, is basically the total population of the state of Texas. In 1900, we were around 2 or 3 million people. In 2010, we're up around 25 million. I think Chairman Bugg talked about the population just for the state of Texas just going up, 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 up. Okay, the other line part of the graph, which is the red line, is actually based on the vertical axis on the right-hand side of the screen, which is the percentage of the population that lives in an urban or urbanized area. Okay, this is from the census data. Again, so if you'll notice, in 1900 it was around 20 or percent or less, and then up it goes. Of course, in the post-war period, it took a significant jump. And up it goes. The last census data had us up around 84, 85% in the urban areas. So we're increasingly being asked, and I sort of make the comparison back in, because it's our 100 years of TxDOT, 100 years ago, and somewhere between 1910 and 1920, right, we were at 3.5 million people roughly in the state, and only 25% of them lived in the urban area. Contrast that to what we're at today, 100 years later, and most of us live in the urban environment. So we need to start thinking in those terms when we start talking about our facility design. So here's a typical section that we'll get in to the design division. They're expanding a roadway. I don't know where this road is, but it's in an urbanizing area. Okay, it's a growing area. Obviously, they're adding lanes in this particular proposal. We got 4 12-foot lanes. We've got the 14-foot continuous left turn lane. I've got 2 10-foot shoulders, curb and gutter in this place, and they've tacked on a 5-foot sidewalk on the side of it. For some reason that doesn't really, in my mind, satisfy the pedestrian design component if this is an urbanized area. So this is sort of the highway. I mean, you guys, we've been talking about highways and highway design all morning. Very linear, very single purpose, very structured, highly engineered. We like predictability. We like, very, very systematic approach. And so forth and so on. The problem is when we start talking about pedestrians, quite frankly, you can take all that roadway design manual and throw it out the window because they defy all of that stuff. Okay, the things that a good, comfortable pedestrian space is the entire, is the exact opposite of the roadway components. It's multi-purposed, it's flexible, it's more spatially oriented, and so forth and so on. So how do we bring the two together? This is going to be our challenge going forward. How do we start making a system that is truly multimodal, that accommodates the traffic, accommodates the freight, but it still accommodates the bikes, the pedestrians, and any other users that may be out there. So this is our challenge, and there's a couple of monikers that have been sort of thrown at this, context-sensitive design. The complete streets is one sort of concept that's thrown out there, and I'm not saying that we have to do this, obviously, on all roadways, but I think as the population changes, we are going to be asked more and more to accommodate, really, truly accommodate pedestrians. And start looking at these kind of facilities. So it's going to be a real challenge going forward. just some examples of sort of what we've started on, and I'll lead into Anna's presentation next. She's going to show some projects they've been working on down in Houston. You know, we're going to have some multimodal challenges. There are conflicts between the vehicular traffic and the pedestrians and the bikes and the skateboarders and so forth and so on. So it is going to be a real challenge. And then when we start introducing the sort of those free flow intersections, some of the alternative intersection designs, it's going to even get more complicated. Again, you know, I want we as a department to start taking some of these things into account and paying attention, you know, and really making that pedestrian functionality a key piece when we're in the urban environment. And I think increasingly we're going to be asked to do so. So that's sort of what I've got. Here's our palette. Let's get to work. Back it up.
Go back to slide 11. Yeah, right there. Can you explain that top right?
That top right is, I got this, I actually borrowed this from a guy who had just been overseas. I think it's in, I can't even remember. It's a roundabout, but it is obviously not in the United States of America, so they're going backwards. And I'm assuming that's like a yield type, shark teeth yield. Again, I should have gotten a mirror image. I should have flipped it around. You guys never would have picked it up. But I think this, well, you would have seen the signage that's different, obviously. Obviously, it's a European design. But you know, I think the roundabouts are, you know, I don't know if they're going to come in the state of Texas or not, but they're coming around the rest of the United States. So it's something, you know, how do we handle the pedestrians? And I'll make one quick point, and it's sort of keying off what Marcus talked about. You know, who is our design pedestrian? You know, who is that person? More than likely, they're either real young because they're not drivers yet, or you know, perhaps mobility impaired, perhaps disabled. Which, you know, our disabled community is more likely to be on transit or on foot rather than in a vehicle. So again, a whole range of abilities, a whole range of you know, physical characteristics of our sort of design pedestrian, if you will. So there's you know, obviously a lot of different factors that we sort of need to work into the mix.
One more thing about when you said it was linear, you said it was linear and stuff like that. I don't know what the alternative is. Go back to that section.
Right here, yes, and the alternative in the transportation world is there is not an alternative. I mean, I'm not suggesting that we change the highway design at all, nor am I really suggesting that we build parks up and down every road. The point was that you know, the spaces that we as humans feel comfortable in are not necessarily these long linear you know, spaces. You know, they're more compact spaces. They're more human scale, if you will. So the point was that, you know, the human sort of component is different than the automobile. You know, the physics of the automobile that we generally work in. But getting from point A to point B, obviously they still will be, you know, a linear. Folks want to get to where they're going to, and you know, the quickest way is a straight line. So, all right, with that, I will turn it over to Anna.